I'm Andreas Hamberger, and this is the Hamberger Report, where I cover AI governance, enterprise architecture, and the technology decisions that actually matter to the people who have to make them. If you find this useful, subscribe and hit the like button. It helps more professionals find the channel. Now let's get into it. "10 minutes. That is how long it took for me to be offered the role of Technical Services Manager at the top ISP in New Zealand. No panel interviews, no psychometric testing, no competency framework. 10 minutes of conversation about what I had built, and it was done." I'm Andreas Hamberger. This is the Hamberger Report, where I cover the untold history of the operating system that runs the world. This is episode 4. The episode where Linux stops being something I was learning in a bedroom and becomes something I was running at national scale, and where the 10-minute interview in Auckland taught me a principle about hiring and competence that I still apply 30 years later. Late 1996, I had just arrived in New Zealand from Austria. 2 years of web development experience, a head full of Linux, and very little idea what the local tech scene looked like. I found ICONZ almost immediately. The internet company of New Zealand was running Linux in production. Not as a curiosity, not as a lab experiment tucked in a corner. Linux was the backbone of a commercial ISP, serving paying customers across the country. Long for someone who had spent the previous 2 years building websites in AMS and compiling kernels on a 486, this felt like walking into a room where everyone already spoke my language. I applied, I sat down with the general manager and the outgoing technical manager. 10 minutes later, they offered me the role Technical Services Manager, responsible for the Security Operations Center, the Network Operations Center, product development, technical budgets, and a help desk with 15 support staff. I had not finished my coffee. To understand why that 10-minute interview happened, you need to understand the economics of running an ISP in the mid-1990s. ICONZ was founded in 1992. John Clark transformed his status bulletin board system into the Internet Company of New Zealand and relocated from a Parnell garage to Airedale Street, directly opposite Telecom's central Auckland exchange. By 1994, the operation had grown to 18 dial-up lines and a 48 kilobit circuit to Auckland University. By 1996, ICONZ had expanded to branches in Auckland, Wellington, Hamilton, and Christchurch. The company was, by most measures, the top ISP in a market that now included roughly 30 providers serving more than 160,000 New Zealand internet users. Running an ISP in 1996 meant running infrastructure on a budget that would make a modern cloud architect pause. Every dollar spent on software licenses was a dollar not spent on bandwidth, hardware, or staff. The commercial Unix variants that dominated enterprise computing, Solaris, HPUX, AIX, were priced for corporations with deep pockets. A small ISP in Auckland could not afford per-seat licensing for an operating system, plus a mail server, plus DNS, plus a web server, plus support contracts on all of it. Linux changed that equation entirely. The kernel was free, SendMail handled email delivery, Bind resolved domain names, Apache served web pages. The entire stack a commercial ISP required, from operating system to application layer, could be assembled from freely available components. This was not a philosophical statement about software freedom, although the philosophy mattered. This was survival arithmetic. ICONZ could serve a country's internet traffic because the software cost was effectively zero, leaving the budget for what actually constrained growth, bandwidth, hardware, and people who knew how to keep it running. Then in June 1996, Linux kernel 2.0 arrived, the first release with symmetric multiprocessing support. The kernel could now use multiple CPUs on 32-bit systems for an ISP handling increasing connection volumes. This was a meaningful step from capable experiment toward production platform. The timing was right. The infrastructure behind the mid-1990s ISP was simultaneously simpler and more precarious than anything we run today. Dial-up modems were the front door. Customers connected at 28.8 or 33.6 kilobits per second over analog telephone lines. Each connection consumed a physical modem port and a phone line. Scaling meant buying more modems, more phone lines, more rack space. There was no virtualization. There was no elastic scaling. Capacity planning meant counting physical phone lines and hoping you had ordered enough. Behind the modems sat the servers. A typical ISP of this era ran a handful of Linux machines, each handling multiple roles simultaneously. One server might run send mail for email, bind for DNS, and Apache for web hosting at the same time. Separation of concerns was a luxury for organizations with larger budgets. You made what you had work. ICONZ's leased line to Auckland University ran at 48 kilobits per second. To put that in perspective, a single high-resolution image on a modern website would saturate that link for several seconds. Every byte mattered. Every service had to be lean. Monitoring was rudimentary by any current standard. You watched system logs, you wrote shell scripts to check disk space and connection counts. You set up pagers for the truly critical alerts. When something failed at 3 a.m., someone drove to the data center. There was no remote management console. There was no cloud dashboard. There was a person with a car key and knowledge of which server needed to be power cycled. This was the environment I walked into, and it was exactly the environment where Linux thrived. There was a cultural alignment between early ISPs and the Linux community that went deeper than economics. ISPs in the 1990s attracted a particular kind of person. The work was technical, unpredictable, and constant. You built systems during the day and debugged them at night. You wore every hat because there was nobody else to wear it. You learned by breaking things and then fixing them under pressure. Linux attracted the same temperament. The operating system in 1996 was powerful but not polished. Installing it required patience. Configuring it required reading documentation, searching mailing lists, and occasionally reading source code to understand why something was not working. The reward was complete control. If the software did not do what you needed, you could change it. You could recompile the kernel with exactly the drivers your hardware required. You could patch a bug yourself rather than waiting 6 months for a vendor to acknowledge it existed. Moving from Austria to New Zealand at the end of 1996 meant moving from a dense European tech ecosystem to something smaller, more concentrated, and more resourceful. In Europe, Naval was still dominant in networking. The talent pool was large, and the vendor options were many. New Zealand in 1996 was different in scale, but not in ambition. Internet uptake was among the highest in the world, growing at roughly 15% per month. Telecom had just launched Extra, bringing serious corporate resources into a market that had been built by garage entrepreneurs. The competition was intensifying. What New Zealand lacked in scale, it compensated for in necessity. A small Auckland ISP could not hire a team of Solaris administrators and a separate team of network engineers and a separate team of web developers. It needed people who could do all of it. People who had built things themselves, understood the full stack, and could troubleshoot under pressure. I had been building websites for clients in Innsbruck, writing HTML in AMAS, working with GNU tools on AI prototypes at university. When I described that work to the ICONZ team, I was describing building things with the same tools they were using to run a national ISP. The GM and the outgoing technical manager recognized that in 10 minutes, not because my CV was impressive, because I described solving the same kind of problems they faced every day. My responsibilities at ICONZ went well beyond keeping the servers running. I became a founder of the New Zealand Network Operators Group, NZNOG. Network Operators Groups are where ISPs, telcos, and infrastructure providers share operational knowledge, coordinate peering arrangements, and solve the collective problems that no single provider can address alone. In a small market like New Zealand, where a handful of providers carried the country's entire internet traffic, This kind of cooperation was not optional. It was the only way the infrastructure worked. The help desk was a different kind of challenge. 15 support staff handling customer queries for a service that most of those customers barely understood. The internet in 1996 was new to most New Zealanders. Modems needed configuring, email clients needed setting up, connections dropped and nobody knew why. Our help desk won customer service awards, not because we had better tools than anyone else, because we had people who understood the technology well enough to explain it simply. That is a harder skill than it sounds. Technical budgets, staff appraisals, professional development, product development. The role was everything at once. In a startup ISP running on Linux, there was no separation between the person who planned the network architecture and the person who crawled under a desk to replace a cable. That was the job. That was why 10 minutes of conversation was enough. That 10-minute interview in 1996 was not reckless. It was pattern recognition. The GM and the outgoing technical manager were not looking for credentials. They were looking for evidence that I had already solved the kind of problems they faced. Can you build and run Linux infrastructure? Have you done it before? Can you think on your feet when something breaks at 3 a.m.? The same pattern recognition plays out now in hiring for AI roles. The most valuable people in AI-integrated organizations are not necessarily those with the most impressive qualifications. They are the people who have already used AI to solve real problems, who have built workflows, tested outputs, identified failure modes, and developed processes that produce reliable results under operational conditions. The tool chain changes. The principle does not. In 1996, the question was, can you make Linux serve a country's internet traffic? In 2026, the question is, can you make AI systems work reliably and transparently within the governance frameworks your organization requires? The people who can answer yes with evidence will always be hired faster than the people who can only answer with qualifications. Show me what you have built. Tell me what broke. Explain how you fixed it. In the next episode, we move deeper into the New Zealand story. Linux is no longer just running an ISP. It is about to become the subject of a bet, a number plate, and a decision that will define a career. If you enjoyed this episode, subscribe to the Hamberger Report. New episodes in the History of Linux series every Wednesday, and new videos every day. That is the Hamberger Report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.